Here in these next two examples in the Module 2.2 class notes, we are looking at domain and range of a quadratic function. I can note very quickly here that a quadratic function, whether it's written in standard form like this one is, or if it's in that ax squared plus bx plus c form, you do not have any square roots of x here. No. That never happens with quadratic functions, nor do you have any division by x, fractions involving x in the denominator. That never happens with quadratic functions. In fact, it never happens with polynomials, period. So because we don't have any radicals and we don't have any fractions with x in the denominator, that means, recalling our discussion of domain from Module 1, that means that there are no domain restrictions. And so always and every time we look at a polynomial function, or a quadratic function in particular, the domain is all real numbers. Simple as that. The range takes a little more work, not terribly much more work, but let's consider the range of this polynomial function. And we'll note the domain and range both in our answer, but I already know the domain is going to be all real numbers. Let's focus on the range. And the range is going to be determined by some pieces of information that we're actually already familiar with, and that is, first of all, which direction is this quadratic function opening in? Is it opening up? Is it opening down? And the a value tells us a here, a equals -2, that's less than 0. A is negative, that means we're going to be opening downward. We're going to have a parabola that is opening downward with a point, the vertex, at the top of the parabola, a maximum value. So we have a downward opening parabola with a maximum value, and if that's my kind of thought of the sketch of the graph of the parabola, then I see my range is going to continue down forever to -infinity, but it's not going to go up forever. It's going to stop at the vertex. So I need to know what the vertex is. Let's consider here that we already know that, because the function is written in standard form. X minus h plus k. X minus -3, that means that h is -3, and plus k means that k is -6. Then matching our given function up with the standard form that we know, a times x minus h squared plus k, gives us the vertex -3, -6. So that's the point that we have for the vertex here at the top of the parabola. So as high as this graph is going to reach, the highest this graph is going to reach is a y value of -6. And it's going to open down from there. We have enough information now to complete. We know the domain is all real numbers, and the range is going to end at the highest point at -6 and go down to -infinity. So always writing from smallest to largest, we're going to go from -infinity all the way at the bottom of the graph up to -6 at the vertex. So the range -infinity, -6 then is our answer. Let's work another example here, determining the domain and range of this quadratic function. The only difference here is that this quadratic function is given in the ax squared plus bx plus c form. So it's going to be a little more work to find the information we need, but the information we need is the same. We need to know the direction of the parabola, whether the graph is opening up or down, and then we need to know the vertex to see where it stops at that maximum or minimum point. With an a value of 1 here that is greater than 0, we know that this parabola is going to open upward and thus have a minimum point at the vertex. A minimum point there at the vertex. So the domain here, well, the domain we already knew is going to be all real numbers. The range here is going to start at some bottom point at the vertex and then increase up to infinity. I need to find the vertex to know what that is, that minimum point, and I'll use my trusty h equals negative b over 2a formula here with b is 6 and a is 1. So negative 6 over 2 times 1, that's negative 6 over 2, that's negative 3 for the x value of the vertex. Then plug that back in to find the y value, f of negative 3, that's negative 3 squared plus 6 times negative 3 plus 4. That's 9 minus 18 plus 4 is negative 5. Negative 5. That means I now know my vertex is negative 3 comma negative 5. Negative 5 being that minimum value that's as low as the y values reach. From there, starting from there, my graph opens up and continues on to infinity. So my domain, all real numbers, we knew that. Then the range begins at negative 5 at the vertex and continues up from there to positive infinity.